to keep in mind that a lot of this is stuff you have seen before, okay? So if you feel like bored, I'm so sorry. We are going to get through it pretty quick, and we will move on to things that are a little less familiar for some of you. But we are going to go ahead and look at our number systems. So when we think of numbers, okay, there are two main number systems that from those two, everything else is broken up into. So we have our real number system, which is what we think of when we think of numbers. That's what we've been using basically our entire math careers at this point. And we also have the complex number system, which includes imaginary numbers, and we're going to actually get to that a little bit later in the year. It'll be after Christmas sometime. I think it's like around Mardi Gras break. But that is when we will get to that. But for now, we will stay fully in the real number system. So the real number system is then split into two categories that we can think of all numbers as a part of. The irrational numbers and the rational numbers. So just for a second, I want you to think, what does the word rational mean? Logical, yeah. What about irrational? Yeah, if someone is being irrational, what are they doing? Being crazy, right? So what is a number? When I say irrational number, what number do you think of? Pi. Why pi? Because it just goes on forever, right? So that decimal never ends. So pi is an irrational number. The reason being is because it is a decimal that never ends. And we're also going to include that it has no repeating pattern. Now, pi is not the only irrational number, okay? If we go by that logic, is there any other numbers you can think of that would be irrational? What was it?
Repeating decimals?
Well, we're no repeating decimals because we have no repeating pattern.
Or like
That don't, yeah. So like we could have like the number 5.12345, 12345, 12345, 12. That's a repeating pattern. 12753562237, and it just keeps on going forever, right? Now there are some other numbers that we can use that we can think of that are automatically going to be irrational. So if we try to take the square root of any number that's not a perfect square, those are going to be irrational numbers. What's a number that's not a perfect square? 7. So if I go and I try to take the square root of 7, I get 2.645751,311. And that's just what my calculator will tell me. That is an irrational number. Anything we can't take the square root of would give us that. What's another number I can't take the square root of? 3 or 5. Okay, both of those things. Okay, because 3 would be 1.732050808. Yeah, square root of 3. Okay, it can also be the square root of 72. Anything. Okay, it can be the square root of, or negative square root of 72. That would be irrational. Okay, anything like that where the decimal does not end is considered to be irrational. So on the flip side of that though, if we have decimals that do end, that would be considered rational. So over here next to rational, oh good gracious, we are going to put all fractions and decimals that end. So my examples for that, 12, that's a rational number. What else could be a rational number?
five.
What about one that fits the fractions part of it? 1/2, 2/4, yeah. We can also have improper fractions. What's an improper fraction example?
8/2. Oh.
8/2, but that simplifies though. 7/2, that works. Or 7/3.
I like that one.
Then let's see. What would be a decimal that ends? Where 3.7? Yeah, we can do negative 3.7. Just because it can be positive or negative. You know. Rational numbers are just something we can express easily, essentially. That's what it is. And so from there, rational numbers can keep getting more and more specific as we go. So from here, it's kind of like, you know those little dolls where they like go into each, like that can like all fit together like Russian nesting dolls? Yeah, the nesting dolls. That's kind of what happens here. So like all rational numbers are real numbers, right? But not all real numbers are rational because some can be irrational, okay? And that same thing happens in the same pattern here. So what do you remember of an integer? What's examples of integer? 1 is an integer. -1 is also an integer. What makes integers kind of cool is it's the negative and positive numbers. But it's specifically the ones that are like listed out on your number lines. So like -2, -1, 0, 1, 2. And it can keep going in both directions. So like -57 is an integer. +32 is an integer. 0 is an integer. Okay? What about whole numbers? How does that?
The positives?
Just the positives plus what? 0. So whole numbers are going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever, right? Then natural is the whole numbers excluding 0. So it's just 1, 2, and so on. So what we're going to do is we are going to name the subset of the real numbers that which those numbers belong. So we're going to do the most specific we can get. So if I told you -32, -32 is a rational number, right? But what is -32 also? An integer. So I would say integer because it's more specific. It's the more specific subset for what we're doing. So that's what we're going to do. So for 25, what's the most specific we can get with 25? Natural. All right. For -12, what can we do? Integer. For 3/7, rational. For the square root of 21, irrational. Because we can't take the square root of 21. It's not a perfect square, so that makes it irrational. What about 0? The negative square root of 16. It will be rational, but why? What is the square root of 16? 4. So that's actually -4. So what is that really going to be? Not just rational, but it's a integer. Okay, for 7, what is that one? It is rational, but it can be simplified. So what does it get simplified to? 2. And 2 is a natural number. Okay, pi. What about 5.3? Rational. Okay, for 10. What is the square root of 81? So that's actually 9 divided by -3. What is 9 divided by -3?
-3.
So that means what?
Integer.
Integer. All right, for 11, we have negative 2.875. It's rational because it's got that decimal. Integers will not have decimals or fractions. Why is it natural? So it's just 1. All right, so now we're going to go over some questions with operations just to get our brains back in math mode. With math, what is an operation? There's 4 of them.
Add, divide, multiply, and
Subtract, yes. So we're going to look at addition and subtraction first, okay? And we're just going to real quickly do these. No calculator. So for number 1, what is negative 7 plus negative 4? Negative 11. Why is it negative 11 and not negative 3? Because they're both negative, right? So we have negative 7 and then we have negative 4 more. All right, for number 2, we have negative 2 minus 5. It's going to be negative 7. Because again, we're at negative 2 and we take away 5 more. All right, for 3, we have 3 minus negative 2. What happens when you subtract a negative number? You add. So what is 3 plus 2? What is 5 minus 5? Now,
Juniors is the last name, and if you receive, please report. Libraries, please report to the library. Also, I'm going to try to email to teachers, knowing what letter that needs to go to the library. Thank you.
all right, so for 5, to add or subtract 2 fractions, what do the 2 fractions have to have? The same denominator. They have to have common denominators. Now, for this particular problem, would it be easier to make the 2 4 or the 4 2? To make the 2 4. It's easier to make them bigger. Now, when I do that, what do I need to do to make that denominator go to 4? Multiply by 2. Do I just need to multiply by, how do I need to go about it? I've got to do 2 to the top as well. The reason being, if I just multiplied it by 2, okay, that's going to change the problem. But if I do 2 over 2, what is anything divided by itself? You can multiply anything by 1 and it doesn't change it. So that's why we have to do it that way, so it doesn't change what our problem is. It just changes what it looks like. When I multiply fractions, we go straight across. So 2 times 1 is? And then 2 times 2 is? Then we have 2 fourths minus 7 fourths, which gives us negative 5 fourths. Yep, there we go. Now, for 6, do I need to do anything to be able to add or subtract those? Okay, so I can just simplify. So what is negative 5 sixths plus 3 sixths? Negative 2 sixths. Can I simplify that? To what?
negative 1 over 3.
How do you simplify a fraction? What are we doing? We would divide both of them by 2 or whatever the common factor is with them. All right. Now, we're going to go ahead and look at multiplication and division. So, what is negative 10 times negative 3?
30.
Positive 30. What about 8 times 6?
48.
Now, I'm going to let you know this little bitty fact about me, okay? I have 2 degrees in math, and I have taken so many math classes. I have taken all levels of calculus, I have taken differential equations, I've taken all sorts of probability and statistics classes. I have taken so many math classes. My 8's times tables, I don't know them. If it's multiplied by 8, I'm gonna need a calculator, because for some reason my brain refuses to grasp the 8's times tables. It has been that way since I learned my times tables way back in the day. Like, there was a time where I knew my 13s and my 14s. I couldn't do my 8s. It's frustrating. And so, whenever we have a problem with an 8 in it, because I give us problems with 8 in it in hopes that one day my 8's times tables will magically appear in my brain. I'm going to look, if you ask me the ones where it's times 8, I'm going to look at you and be like, because I just genuinely forget my 8's times tables. So, I say that, A, to let you preface the fact that I'm going to ask you the 8's times tables because I don't know. And B, it's okay not to know something. Just keep trying, okay? So, my 8s are my struggle though. So, you will, if I have a problem with the 8s in it and you look at me and I look confused, I'm going to doubt you of whether or not it's right every single time. I have it worked out over here and I still just like feel like that's wrong just because I don't know. But it's okay though. Our 8's times tables will stay that way for me. It'll be okay. Y'all just have to have my back on my 8s. And I got your back on everything else. So for number 9, can I multiply these two things together? What do I need to do to the 5 to be able to make it to? Yep. Now, I can multiply these straight across. The only time you cross multiply is if there is an equal sign in there. You do not just cross multiply when you're doing this. Don't cross multiply, please. Okay? So, we're going to multiply straight across. So, 7 times 5 is? 4 times 1 is? Can I simplify that any? We will leave them as improper fractions. We don't really use mixed numbers in algebra. Yeah. But there is nothing that can go into both 35 and 4. All right, for 10, a negative and a negative make a? And then we're multiply straight across. 7 times 8 is? 5 times 4 is? What was that? Yep. Now, can I simplify 56 over 20? What can go into both 56 and 20? 2 can. What else? 4. What is 56 divided by 4? Does anybody know? – 14. What is 20 divided by 4? 5. So we can simplify that to 14 fifths. All right, now, 24 divided by 4. 6. Fun fact, 24 is my least favorite number. Too many things go into it. It's too small. Because think about it. You have 1, 2, 3, 4, 6, 8, 12, 24. That's a lot of numbers for like a small number. You know? I don't know. It bothers me. I don't like the number 24. You're learning all sorts of weird facts about your math teacher today. All right. For 12, what is 1 divided by negative 1? Not just 1, but negative 1. All right. How do I divide by a fraction? What is it? What is that? We're not going to do that. We're not going to put them in decimals. Keep, change, flip. So what that means, okay? We keep the first thing. Change the sign. So instead of dividing, we're going to multiply. And then we are going to flip the denominator to 4 over 3. What is the mathematical term for us flipping a fraction? Starts with an R. Reciprocal. So whenever you have to divide by a fraction, you need to multiply by the reciprocal. Keep, change, flip. Now we just go straight across. 7 times 4 is?
28.
4 times 3 is? And can I simplify that? What can I take out of both 28 and 12? So what is 28 divided by 4? What is 12 divided by 4? Perfect. Because you could technically get away with canceling that part right there. Yep. Now, for this one, I'm dividing by a fraction, so that means I need to. Yep. So we're going to keep our -1, change our sign to, and then I need to flip the fraction to 7/4. I have to put a 1 under there to multiply. Now, what is -1 times 7? What is 1 times 4? And can I simplify that? So that's my answer. All right. Now, we are going to look at order of operations. Yep. So whenever we're looking at the order of operations, all right, we are going to be simplifying an expression using a specific order. So we're going to be simplifying an expression using a specific order. And what would that specific order be? PEMDAS. Or I was so lovingly told my entire elementary school career, please excuse my dear Aunt Sally. Now, so the first rule of PEMDAS is what? What do I do first? Parentheses. Parentheses. Oh. All right. Not only does it include parentheses, but it also includes any other grouping symbols. So this can be included as having your parentheses, your brackets. We can even include absolute value bars in that, just because it groups some part of the equation together. Now, what comes after parentheses? Exponents. So from exponents, that one's pretty self-explanatory. What's after exponents? Multiplication and division. Why do you think I put those together? They're very similar. And also, what order do we do them in? Whatever comes first, right? So for multiplication and division, we just go from left to right. Then after multiplication and division, it is what? And what order did those go in? Whichever's first. So again, would just be left or right. All right, so we're going to do the odd ones of these for sure. We'll see what time we have when we're done. So for number 1, what do I need to do first?
We need any juniors that have not taken their advice, so please support the library at the time. Any juniors that have not taken their advice.
So I could put a 1 under, give them common denominators, do it that way. But what else could I do? Yeah, you can go. So what do I need to do first? I could change it into a 2. I could divide first. What is 4 divided by 2? 2. Yep, that's a whole lot easier than doing common denominators than doing it. So we get 2 plus 5, which is 7. All right. For 3, what do I need to do first? What is 6 squared? So we have 36 plus 4 minus 6. So what is 36 plus 4?
40.
What is 40 minus 6?
34.
All right. Then for 5, what part do I need to do first? The whole parentheses part first, right? So what is 6 minus 3? Plus 5. 8 minus 2. So all of that right there is 6. So we have 5 plus 3 times 6. So what do I need to do first now? I have to multiply first, right? So we do 5 plus 3 times 6, which is, and what is 5 plus 18? 23. All right. And we are going to wrap there today.